Hey, good morning, folks, or I suppose afternoon. But this is pre-calc section P5, solving equations graphically, numerically, and algebraically. Okay, so after I'm doing this, I can solve equations graphically by tracing, finding intercepts and zeros, and the intersection. So we'll work with those things on the graphing calculator. We'll solve equations algebraically, and but for linear, using properties of algebra. For quadratic, we'll be factoring, extracting roots, completing the square, and doing quadratic formula. And then we'll also solve equations numerically using tables. Note, while graphic calculators will be used quite a bit this year, our emphasis will be on the algebra behind every problem. Feel free to verify your solutions with the calculator, but don't rely on it. It is used very little in calculus. Always try to picture what the graph should look like before you grab your calculator. You should be developing your mathematical common sense. And as I said the previous day or yesterday in class, make sure all the stuff we're doing in class, except for the number crunching and the linear regression, cubic regression, quartic regression stuff, that you can do it without a calculator. Now, solving equations graphically. To solve the equations such as 2x minus 5 equals 0, you can graph y is equal to 2x minus 5 and find where y equals 0. Okay, the x-intercepts are our concern. So that's would be our solve. Okay, or when y is 0, the zeros is what we normally would call it. So if I was going to put this in my calculator, just to get in the habit of doing it, I would just pop it in my calculator. Let me clear these out and turn off that other plot, because those other plots will turn on and get in the way of my equations. So I've got 2x minus 5. So we're putting in this linear equation. So we have a linear binomial. I hit enter, I can graph, but I want to do a zoom fit for my window. So I can go down here and zoom stat, and zoom fit is the next one. It's 0 actually, and I'm going to show you where that's located. So that's zoom fit right here. So it's zoom fit. You know, it works quirky, but most of the time it should come up, and there is our graph. Now, it does not look like the graph I have on the notes. You got to keep in mind it fit to the window for a graph. Well, let's talk about the window itself here. So I got a viewing window. X's are first, Y's are second. So I'm going to take and put my X's first. I'm going to hit window in my graph. So I'm going to go here and hit window. And then I'm going to change it. And wow, look how big that window is. So although my graph fit in my window, it wasn't the window quite I was interested in. So I'm just going to put in the exact same window they put in there. So I'm going to hit negative 4.7. You know, I suppose we could just put in negative 5. Let's do that. Let's clear that and go negative 5. Make sure you use your negative key versus your subtract key. If a lot of people are like, Bloom, I did it, that's one of the issues, is that you just kind of use the wrong key to enter your graph. So those are my x, min, and max. Now let's go to my y's, and my y is negative 10 and 5. So let's delete that, and I think I can just click over it and it'll be fine. The y-scales means I'm going to get a tick mark every time, and the x-res stuff we'll talk about another time. But now I'm going to graph, and now my graph looks very similar to what we're doing. Now, if you keep in mind, if we're going to talk about trace, right here on top, I have calc, table, and trace is right here in this. So if I hit trace, I can trace, and then I can arrow along. My left and right arrow will move my x value down, and my tracer will just bounce on where in the axis on y it'll be. Now if I have a second graph, the up and down trace lets me bounce from one graph to another. Okay, so I can figure out where my trace is. So I can come down here and trace here. Now, if I set this up right, or if it's really nice, if my window's big enough, I can actually see a 0 come in, okay? 2.5, y equals 0. And I'm very confident that you've used this before. So now, as we're going along with the other information here, you can use the 0 or intercept option on the calculator. okay? And the 0 or intercept option under trace, I should go second calc, I believe. I've got the 0 option and I got the intersect option. Let's look what those two do. Okay, so in 2, I can hit enter, okay, and would be left bound. When I do the left bound, I gotta be on the left side where I think the 0 is. So, and I can be anywhere on the left bound. I hit enter. And then I gotta go to the right bound. I gotta go to the right side where I think there's a 0. And I hit enter. And then they say guess, and I think it's 2.50. Not that I saw it before, but I think it's 2.50. And hey, look, it worked. So that's one way I can use trace in my calculating options to find zeros, because sometimes it's not as nice as what it was on this graph and as I traced right to that point. Now there's also the intercept. If I go to the second calc, okay, there's also the intersect, okay? Intersect is for graphs themselves. Where are they going to intersect? And I can click on the two graphs. But we just did the 0 trace, and that's what we were looking for. So I'm not looking at two different graphs, so I won't use that at this time. So let's go back to the next options. Verify the solution algebraically. Okay, so I found the x-intercept, okay, when y was equal to 0. So the x-intercept is when y is equal to 0. So I plug in for 0 and I plug this in for 0 and I'm going to solve for x. As I solve, I find out that I get 2.5. So that's my x-intercept, 2.50 or 2.5. To find my y-intercept, remember down here, I would put x in for 0 and I make that change and I can solve, and coming down here I get 0, -5. Now I can also see that on my calculator, I think. I don't know, I have never done that on the calculator. So we're gonna check that on the calculator, because you can call me George, I'm very curious. I know it won't do that at the y, on the y-axis. It'll do that on the x-axis. I'm pretty confident about that. I'm not even gonna waste your time. Okay, so now let's look at example 1, solving by finding the x-intercepts. Okay, so I've got this quadratic right here. So if I want to put it in my calculator, and let me bring that up a little higher so I can actually have the problem up there and my calculator available so I won't cover it up. And I go to y equals, and I already got that first one in there, so I hit enter in case I use that again. And now I'm going to go over here. I've got 2x squared and minus 3x minus 2. Okay, now solve the equation graphically, they asked me to do. So I just, instead of having 0 here, I have this as my y, so y is equal to this. Now I'm going to have a squared window on this. I'm just going to go for window squared, and what that will be, it'll be a standard window. It'll be much like the 6, but I'm just going to have it squared. So I'm going to go 5 on this one. I'm squaring my window and I see my vertex there. Now, as we're going, they're asking, hey, solve by finding x-intercept. Solve the equation graphically. So let's solve it graphically. Let's look at my zeros on my equation. So I hit second, I go to calc, and I want to go 0, so I go 2. Okay, my cursor shows up. It says left bound. I have to go to the left side of one of my zeros. So I'm going to go to the left side of that one. I hit enter. And now I go to the right side of that 0 or below it, and I hit enter again. And that is one of my zeros, -0.5. Okay, so I got -0.5, 0. Okay, that's 1 0. And I'm going to look at my other 0. So I go back, hit second, calc, and I go to 0 for my value 2. And I'm going to trace to the other side. Again, I want to put in the left bound first. So I can be right here, so long as I have a left and right bound around what I think is a 0. Hit that, and then I'm going to hit up here and hit my right bound, hit that, and hit enter, and I have my second 0 at 2 0. So if you weren't familiar with doing that, you now are, I hope. But now let's talk about what it would look like if I decided to do it graphically. So this is my graphic check. Check algebraically, if I'm checking algebraically, this is what's going to do. I'm going to put this function over here, and it's equal to 0. Well, I'm wondering when is that going to be 0? So I'm going to use the idea of zero product rule. Zero product rule states that if two numbers multiply together and their product is 0, then either one or both of them are 0. And so what value are they 0 at? So I'm going to factor this, and I've got the fact that 2x plus 1 times the quantity x minus 2 is equal to 0. And now I got to find when this one is 0. 2x plus 1 is equal to 0 when x is equal to negative 1/2. Well, that kind of runs through nicely. That's what this is. And x minus 2 is 0 when x is 2, and that makes sense there. Well, when x is 2, I've got a graph coming across my line, and I've actually graphed it here on my grid. But we saw it on our graphing calculator, and we were fine, and we were able to do it graphically, and we have the picture, and we know how to trace that graphically, and we know how to use our zero trace, but we also, more importantly, can do it algebraically. The algebraic method, and notice how I'm going in a vertical format to make sure it's easy to follow. Please make sure that you're doing that. Don't just keep working across your page. When solving graphically, if your equation is not set equal to 0, you can enter both sides of the equations as separate y equals equations and look for the intersection. Now, this is a cool thing. Okay, now I can solve this way. I could set this in here, and I'm going to show you the difference here of them because I just solved this over for y. I just subtracted 6 from both sides. But before I do that, I want you to see the separate ones. So in your calc, you're going to have a y1 and y2, so I'm going to put them in y1 and y2. So I go to my y equals, and I'm going to clear it, and I'm going to clear it, and I'm going to go up here and say, hey, I've got an absolute value, so under math, I should be able to get the absolute value. It might be math num. Yeah, I think it's a num. So we're just going to go up there and number, move it over, and I got the absolute value. By the way, this abs isn't a workout program. I wish it were. If I could just get better abs by pushing that number, that'd be awesome. I know, TMI. Okay, so here we go. I've got 2x minus 1, the absolute value. That's been entered in my calculator. Now, I'm just going to put in 6 in my y2. I'm going to use the general note. Remember, y equals 6 is going to be a horizontal line. So now I hit my window. I just did a window that was a standard window. Okay, so we're going to be okay. So we're going to just go ahead and graph that. And I graphed it, and I don't see my 6. 1, 2, 3, 4. Oh, 5. I should have checked my window a little closer because I had the X max and X min, but I did not pay attention to my Y max. So we're going to arrow down and take care of the Y max. So we made it 10, maybe. Okay, now we're going to graph. Now what I want you to do is pay attention to what happens as this comes across. When these cross, this is a 0, and so is this. I didn't have to solve it. I can graph the two sides of the equation, and I can do this for any function. I can graph the two sides of the equation, and the places where they cross are my zeros for x. The y does not matter. The y value, again, I want to emphasize this, the y value does not matter at that spot. Okay? I want to make sure you're clear about that. So I can go to trace, and I want to go, and I'm floating up here, I'm going left, and I can hop functions if I need to. Okay, but now I'm like, hey, I want to know what that intersection is. So I go second calc, and I want to say intersect 5. So now I've got the first function and my second function, and they're going to intercept at the closest spot right there at negative 2.56. Now, keep in mind, it makes sense they intercepted with y equals 6, but again, y is not important. The 0 is negative 2.5. Okay, now let's find the other function, second trace 5, because that's what I'm doing. I'm looking for the intersect. And I'm going to jump functions because it's going to be easier to go straight. Now this is my first function there. And my second function, yep, it's blue, my second function there. And it gives me the other intersection point. Again, I'm just interested in the x-intercept here, okay? So now I've got that going on, and this is the picture that we've been working with right here, okay? So what the heck? What happens if I decided to solve it like this? So if I decide to put that in, and I just am going to change that top function a little bit, I'm going to clear that, and I'm going to go up and go over and show you that if I subtract 6, now I'm subtracting 6. Think about what that function looked like, and I'm going to bring it down vertically 6 units, okay? So look where it crosses. It crosses my zeros at negative 2.5 and 3.5. That's a pretty neat little thing. Remember, I can put them in and find my zeros, and this is what I did. Trace second, calc, and hit number 5, intersect, and you can find your 2.5, you can find your 3.5. But now let's look at it what it is algebraically. So remember, I either have 2 minus 1 is equal to 6 because it's positive, or 2x minus 1 is equal to negative 6 because it's negative. And these are the two things I need to solve when I consider this absolute value. So now I look at it and I got 2x equals 7, and I divide, and hey, look, 3.5 like we thought. And then I go over here and I solve and I get negative 2.5. Crazy stuff, okay? But now you have a way to check your algebraic work with your calculator. Notice how I said check your algebraic work and not do your algebraic work? Notice, when solving equations by finding intersections, the value of the y at an intersection point is irrelevant. The solution is the x value because remember, when we're solving that, we're finding where that function's going to cross the x-axis. Although it doesn't appear to, if I were to solve that function for 0, put everything over on one side and enter it in my calculator, I would actually see the zeros. And that's where the two functions cross would be the zeros themselves. Now on your calculator, solve this one on your calculator and give the solutions accurate to 3 decimal places. So put this in your calculator. See how well we've done this, or at least how well I've taught it so you understand it. So I'm going to put this function in, and you should too. So I already got that up, so I'm going to go 0.0, no, not 0.0, 0.5, and I got myself an x plus 3. And I move on. I'm going to get rid of that. I'm going to delete, not clear, because that's a bad idea. And then in my other function, I've got x squared minus 4. Okay, so x squared, remember we're splitting this. X squared minus 4. Now, I'm going to graph this and see where this comes across. Now, I've got this situation right here is where they're going to cross. So now I hit second, trace, and I'm going to go to intersect, and so will you. Okay, I'm going to intersect close to where they are. Now to have it, I'm just going to go left side here. Willow, stop. Okay, sorry, I went a little crazy. I don't hit enter. And then my second curve is right there. Hit enter. And remember, y is irrelevant. X is negative 2.408. So I got negative 2.408 is my first one. And my second one is arrow over here. Oop, I'm going to hit second trace and go intersect 5 and arrow over and do my next intersection. Remember, what I'm finding is the zeros of this function if I weren't through the painstaking work of solving for it. But this is really quick. This is a great ACT, SAT test skill. And now my second one. Remember, the zero is going to be 2.908. 2.908. And those are my two answers. And this is what I did. I put 1 in Y1 and 1 in Y2, accurate to 3 decimal places. So now, mathematical synonyms. Given a real number x equals a in a function f of x, if f of a equals 0, then x equals a is a solution of the equation, f of x equals 0. X equal a is a root of the function, y equals f of x. X equal a is a 0 of the function, okay. X equal a is an x-intercept of the graph of the function. Wow, all these things that it is. A0 is a point on the graph of the function y equals f of x. So all these things mean the same thing. We're looking where it's going to cross that axis. Oh, I'm just going to make sure I caught everything. Yep, okay, good, we're going on. Now, solving equations algebraically. We'll focus on solving quadratic equations in this section since you have already reviewed solving linear equations. So a quadratic equation in x is the one that can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not 0. So remember, it's a quadratic because it's to the second power, and this is a quadratic trinomial. It could be quadratic monomial or binomial or trinomial that we're working with. But there are 4 methods of solving quadratic equations. Okay, the first one's factoring. Second one's extracting square roots. Okay. Third one, completing the square. I know that's everyone's joy, but we will be doing this a lot. We'll be working on completing the square often. So make it your best friend. And then the last one, just by using the quadratic formula, which is pretty much us completing the square. So keep that in mind as we're going through. Okay, to solve by factoring, you need to use the zero factor property. Well, if two numbers are multiplied together and their product is 0, then one of those two, or if not both, must therefore be 0. So which is the correct solution here? Okay, one is 0, one is -1. Which one's 0 and -1? Ooh, it's this one. So we have that as our correct answer. So now I'll look back at example 1a and resolve it by factoring. You get the same solutions. So we're going to factor this. I'm going to multiply and factor out 2x plus 1 and x minus 2. I'm going to solve my two things here. 2x plus 1 is 0 when x is equal to -1/2. X minus 2 is 0 when n x is 2. So those are my zeros, okay? Or the places on the x-axis my equation will cross. To solve by extracting square roots, you must be able to write the equation in the form ax plus b quantity squared equals c. And remember, when you square root, you get two roots. You get a plus and a minus. So like if I've got x squared equals 16, my answer will be x. If I can actually get a pen up here. I'm not sure why I can't get a pen up here. But my answer should be x equals plus or minus 4. I'm sorry, folks, my pen's not working. Yeah, okay. Well, it'll start working eventually and ruin this, but keep that in mind as we're going. So now our next one, solving by extracting square roots. So I'm just going to take the square root of both sides here. Algebraically, doing that, I take the square root of both sides. Well, in getting that done, I know 2x minus 1 is equal to -3 and +3. So I have two choices. So I have to work both sides. So I have 2x minus 1 equal -3 or 2x minus 1 equals 3. Those are my two options. So I follow through for my answers. Okay, I add 1, and I get divide by 2. I get x is equal to -1. Is one of my solutions, and I get x is equal to 2 as the other of solutions. So let's just check it. -1 goes in, -2 minus 1 is -3 squared is 9. Cool. 2 goes in. 2 times 2 is 4 minus 1 is 3 squared 9. Hey, that works too. So now it's your turn. Let's have you factor this perfect square. Remember, when I tell you they're perfect squares, hey man, go with it. It's a perfect square, so take the square root of this, take the square root of this, and make it happen. So this would be 3x plus 5 quantity squared. This is 36, so I'm going to take the square root of both sides. And now I'm looking at it, it's like, well, if I take the square root, I've got 3x plus 5 equals plus or minus 6. And now I have my two possible equations to set up. I have 3x plus 5 equals -6, or I've got to consider 3x plus 5 equals 6. So now subtract 5, and you got 3x equals negative 11, and divide by 3 and find out x is negative 11 thirds. Hey, let's make sure that we're making fractions our friends on these too, by the way. Fractions are friends, all right? They're not food. Now, 3x plus 5 is equal to 6. Subtracting 5, 3x equals 1, and dividing by 3x is 1/3. So I'm hoping this is going well for you as we're going across on these. Now, the technique of example 2 is more general than you might think, because every quadratic equation can be written in the form x plus b quantity squared equals c. The procedure we need to accomplish this is completing the square. Yay! Everybody's going to be completing the square. Now, I'm going to have you complete the square. And students have been roll their eyes, and they'll also feel like they have this upset stomach and need to go to the nurse because it just hurts too much. The number one problem with that is they've tried to complete the square and they didn't have it properly set up. Rule 1, to complete the square on any quadratic, leading term must be 1, okay? It ain't 1 on that leading term, we're in trouble. Okay, so you divide out, so that if this has got a number in front, you divide it all the way out, all the way through, okay? Thing 2, you must make a perfect square. You are the one that makes that perfect square based on your b value. You take half of b and you cut it in half and you square it, and that's here. But if it wasn't already in the formula, we just changed it. So what we need to do, whatever we add to one side, we gotta add to the other. So that's why we do this step. So now we've made this perfect square. That's why it's here, okay? And we've got to understand that we did this. We construct this perfect square, and now we get to solve for x the way we have been. So to solve ax squared plus bx plus c equals 0 by completing a square, you must first divide by all terms by a. So here, I got 4x squared minus 20x plus 17 equals 0. I am going to divide everything by 4. So I've got x squared minus 5x plus 17/4. It's really easy to work with fractions, right? There's right there. Now, half of 5 squared is 6.25, okay? Half of 5 squared is 6.25 as we're going through this. Okay, half of 5 squared. And people are like, well, what's the deal? Take 25, divide by 4, half of 5 squared, 6.25. But we're going to do this because half of 5 divided by 2, is what we put in there. 5 divided by 2, remember, let's look at this. B, 5 divided by 2 squared, 25/4. That's what it is. And look what we did with 17/4. We shoved it over there because it isn't part of our perfect square. Now remember, I added 25/4 to this side. And so I need to make sure I have a checks and balance thing. I have to add 25/4 to the other side because I'm really adding 0 to make this adjustment. Now, as I go through this, this is a perfect square. X minus 5/2 squared. This is negative 17 plus 25, 8/4. Okay, now I'm going to take the square root of both sides, but remember, 8/4 is the same as 2, and maybe my pen will work this time. Okay, for whatever reason it doesn't want to work, but 8/4 is 2. So that's why, oh, that was almost a pen. That's why I'm going to do square root of both sides. So I'm going to take the square root, and I really wish I could say, not just say it, but actually do. I'm taking the square root. Okay, so I'm going to take the square root of both sides. Square root of this side is x minus 5/2. Square root of this side is the square root of 2, plus or minus, remember. So now I get to add 5/2 of both sides. Okay, so I'm here. I've got this and this. So I get to add 5/2 here, and I get to add 5/2 here. The difference is I'm adding 5/2 to negative square root of 2, and I'm adding 5/2 to positive square root of 2. So that's what I've got for my solution as I step through. So these are my possible zeros. X equal 1.086 or x equals 3.914 to the third digit out, or the third place out. Now it's ugly time. Okay. Now, when you see stuff like this, don't freak out. Just slowly combine terms together, multiply, get things together, get everything on one side. Because remember, ultimately, I got to get everything on one side and see what I've got. So I've got 3x squared minus 6x minus 7, x squared plus 3x minus x squared minus, remember, minus x plus 3. Now, I'm combining like terms. I'm going to get this x squared and that x squared. They're going to be gone. It's going to be 3x, 2x plus 3 there. So, good. All right. And that's 3x squared minus 6x minus 7. And 2, that's gone. 2x plus 3. Now, I'm at this point. I'm going to subtract 2x, so that's going to be negative 8x. And I could even subtract 3 and come up with that with 10. So this is where I'm at right now. Now, I want to check my zeros. I want to complete the square, but keep in mind, this has to be 1. I got to divide everything by 3. Okay, so I have x squared minus 8/3 x minus 10/3. Okay, now I've got a fraction. And able to have half a fraction that I'm going to square, I'm going to multiply by 1/2, and it becomes 4/3. 4/3, so it's going to be 16/9 after I square. But I've got to do some stuff here. I'm going to get this 10/3 over here, okay? So I got my 10/3, but this is that half of 8/3 squared. Half of 8/3 is 4/3, and I'm going to square it. But remember, checks and balances. I added 4/3, I took this, I added this to the other side to get it out of my way because I'm completing the square. So 10/3 is part of the original equation. The change, remember, and it's a even change. It just looks different. I am adding 0. I added this and this. When I add it to both sides, it balances out. So now I square that. Okay, that's gonna be 16. That's gonna be 16/9 on this side. But this side, I'm going to actually factor. It's going to be x minus 4/3 squared. So now I make them both ninths because this is 10/3. 30 over 9 is the same as 10/3. And I get 16 over 9 because that's squared. And I'm going to add those together. So now I have on this side right here 46/9. Okay? But I'm going to take the square root of both sides with 46/9. And I have x minus 4/3 equals plus or minus 46/9. So now I have two relationships to solve for. I have that 4/3 plus or minus the square root of 46, and this square thirds, because I can take the square root of 9, bring that out. So they're both in thirds. And I have these two choices. So if I do the left choice, I got that. If I do the right choice, and I'm doing these in my calculator, I have that. Okay, something that's really kind of a fun deal with this, I'm going to move that over so you guys can see those better, is when I put these in my calculator. Okay, some people kind of groan and moan when they get going on this, but let's go second quit and get to the main thing, and I'll clear this up. So I got 4 divided by 3 minus the square root, second square root of 46. Now I got to get outside and I divide by 3, right? Okay, that's this side. I want to show you, now we got this going on, and I know you're like, Bloom, you're showing me how to intercept my calculator. Some people don't know that they can hit second, enter, and recall everything that you just did. Matter of fact, you can do that for several steps. That's why we don't let you share calculators during tests. But here's the deal, check it out. It is now a plus version if I don't go too far. It is now a plus version if I don't go too far. And I can hit enter, and now that's my other side. So although the first one was really a pain in the derriere to enter, this bad boy ain't so bad now, is it? So I'm able to come up with both answers. As we go on, I think we're done. Nope. Okay, I've still got some stuff for every quadratic equation. Every quadratic equation can be solved using the quadratic formula. Okay, now the quadratic formula is right here. The solution to the quadratic equation, ax squared plus bx plus c equals 0, where a isn't 0. are given by the quadratic formula here. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. There is a song, and I know there are certain instructors that will sing it for you. You don't need me to sing. It's like cats in a dryer. Okay, and by the way, no cats were hurt or thrown in the dryer. I just want you to make believe what that would sound like, and consequently, with that smile, just know I won't do that for you. Okay, so here's the deal. Solving using the quadratic formula. Okay, I have no idea why that didn't disappear. I'm having problems with stuff, apparently. But let's see if I can make that group, and then we'll do that, and we'll pretend that it didn't happen. Okay, nobody needs sound. Did that really just happen? Okay. Hey, let's make it behave like it didn't happen. Hey, look at that. Now, here's the deal. I rewrite my equation. I get 5 over here. Solve the equation. Now, I have A, B, and C. My A is 3, my B is -6, my C is -5. I can now plug them into the quadratic formula accordingly for A, B, and C. Remember, it's got to be in descending order, and that's what this means. As I plug stuff in, I got the opposite of -6 is 6, plus or minus b squared, which is 36, plus negative 4a, it's 12, times 5, which is 60. But that's a -2, so that's why it's plus 60. And now I combine like terms underneath my square root, and I have this plus or minus. So now I have two versions of my answer. I have 6 minus the square root of 96 over 6, which is, in my calculator, 0.633, or x is equal to 6 plus the square root of 96 over 6, which is here. What's that look like in my graph? I can put that in my graph, and that's what it is. So I can, if I wanted to, okay, just to double check to make sure I'm doing stuff right. Let's put this over here so we can see what I'm doing. So I've got y equals, I'm going to clear that, and I'm going to clear that, and I have 3x squared minus 6x, and remember it was minus 5 because everything's my graphing calculator. And now I'm going to graph this puppy, and there it is. Well, remember, second calc 0. Let's go to 2. That'll be fun. So now I got to do a left side of my 0, and it's left to right on my x-axis. So now my left bound, now my right bound, because I'm on either side of 0, and I hit it, and it goes -6, excuse me, -0.6329. Hey, weird, it's right there, -0.633. Wow, I wonder if this other one's over here. Let's just check that out. So second calc, again, I'm doing 0, so it's 2. And I pop over there. Boop, 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 boop. Now remember, it's the left bound. As soon as I have something on the left side, I can do this. But I have to have something on the right side of my 0. So it's got to be on the right, someplace. Look at that, 2.6329. 2.633, oh, crazy, that's the answer. So that's how I do it on the calculator. This is what it looks like if I do my figures by hand. So now it's your turn. Please do B. And these are our answers. I'm not going to be secretive about it. I just want you to work through and get them. So turn it off and try it. Okay, welcome back. So we got everything here. I got A is 2, B is -3, C is -1. I got the quadratic formula. Every time you use a formula, write it down. You will memorize it. Okay, plug in my stuff. I got -3 is 3, opposite, and 9 and 4AC. I'm a little concerned about that. 4 times 2 and 1 is +8. Shoo, that's right. Okay, so I've got that plus or minus the square root of 17 over 4. So now I've got my two choices, and I worked it on my calculator, and these are them. And I double checked my work using my calculator. And notice you can double check your work using your calculator, but do the work first. Okay, now be sure you know all 4 algebraic methods for solving quadratic equations, and think about how you decide which method to use. Now, keep that in mind as we're going through. Okay, I'm going to be back on Tuesday. We'll do the solving equations numerically with tables as we go on Tuesday. But before I get going, I think this is what we got going for today. Make sure you look at your section P5, page 46, 47. I think I got to quadratic formula, and these are all the things that jam with it. I got to that quadratic formula example and it took 40 minutes, and I apologize, but I wanted to make sure everything was clear. I will walk you through how the quadratic formula was formed and how they evaluated and came up with it. Okay, it won't be a secret. I want you to actually try it. It makes you a better math student as we do it. But thank you for your time, and I'm looking forward to see you back soon. Have a great day.